Yeah, it's red line on it. So you cannot hear me?
Okay, now we can.
Oh, okay. Okay. Hi, everyone. So last time we've talked about chapter 2 of our text. So basically, we have talked about various cost concepts followed by cash flow diagrams. So today, what we are going to do is we are going to solve some exercise problems from our text, and then move on to the chapter 3 later. Okay. Okay, the first problem is problem 2-52 from our text. So on December the 1st, R. Smith purchased a car for $18,500, and he paid $5,000 immediately and agreed to pay 3 additional payments of $6,000 each, which includes principal and interest at the end of 1, 2, and 3 years. And the maintenance for the car is projected at $1,000 at the end of the first year and $2,000 at the end of each subsequent year. And R expects to sell the car at the end of the 4th year after paying for the maintenance work for $7,000. And using these facts, prepare a table of cash flow. So the R. Smith purchased a car for $18,500, right? And he paid $5,000 right away, and we're going to pay 3 additional payments of $1,000. I'm sorry, the $6,000 each at the end of the year number 1, number 2, and number 3. So let's make a table of cash flow like this way. So the very first column is called the timeline. And the second column is the purchase price. And next column is the maintenance cost. So let's say operation and maintenance expenses, O&M. And the next one is the service value. The very next column is the total cost. So basically, what you're going to do here is just add up all these 3 values here, okay? And at the end of period 0, 1, 2, 3, and 4, right? Okay, so he agreed to pay $5,000 immediately. So what you need is put negative 5,000 right here. And he agreed to pay 3 additional payments of $6,000 at the end of year 1, year 2, and year 3. And do nothing here. And the maintenance cost would be $1,000 at the end of first year and $2,000 at the end of each subsequent years, right? So you need to put negative 2,000. But there is no maintenance cost right now, right? And also, he's going to sell the car at the end of the 4th year for how much? For $7,000. So you're going to put 7,000 here and all zeros otherwise. So the total cost right now is negative 5,000. At the end of first year, negative 7,000. At the end of second year, negative 8,000. And at the end of third year, again, negative 8,000. But at the end of fourth year, it's going to be positive 5,000. Okay? So what is the main problem? There is the problem 2-52. Okay? So this is very simple question, right? So let's practice with one more problem. So it's 2-53. So Bonka Toys is considering a robot that will cost $20,000 to buy. After 7 years, its service value will be $2,000. An overhaul costing $5,000 will be needed in year 5, and operation and maintenance cost will be $2,500 per year. So again, you are required to draw the cash flow diagram in this case. So you can draw the cash flow diagram directly, but let's construct a table of cash flow first, and then based on that, we can draw the cash flow diagram. Okay? So here is problem number 2-53. So the first column would be the year, second column would be the capital cost, and third column is the operation and maintenance cost, and the last column would be overhaul. Okay. And the year is going to be from 0 to 4, 5, 6, and 7 until 7, right? So the Bonka Toys considering a robot that will cost $20,000 to purchase. So I'm going to put negative 20,000 up here. And after 7 years, its service values will be $2,000. So I'm going to put 2,000 at the end of year 7 down here. And I'm going to put all zeros. And the maintenance cost will be $2,500 per year. So I'm going to put 2,500. I'm going to put negative sign there. So negative 2,500 each until the end of year 7. Of course, there is no maintenance cost at the end of year 0. Okay? And another cost is the overhaul costing of $5,000 in year 5. So I'm going to put negative 5,000 here and 0 otherwise. So based on this table, you can draw the cash flow diagram. So here, arrow pointing down means negative cash flow, right? And times 0, you need to put negative 20,000 down here. And at the end of the first year, you need 2,500. One, let's say 2. And then 2,500 each 3, 4, 5, 6, and then 7. Okay, so you need 2,500 each. However, because of this overhaul cost of 5,000 at the end of 5th year, you're going to have this. Okay, so instead of 2,500, you need to put negative 7,500, which is 2,500 plus 5,000, which is negative 7,500. Okay, so this is going to be the cash flow diagram. Okay, and next problem is 2-54. So Pine Village needs some additional recreation fields. Construction will cost $225,000 and annual maintenance expenses are $85,000. And the city council estimates that the value of added youth leagues is about $190,000 annually. And in year 6, another $75,000 will be needed to refurbish the field. And the service value is estimated to be $100,000 after 10 years. So we need to draw the cash flow diagram for this case. So like before, let's construct the cash flow table first. And then based on that, let's draw the cash flow diagram. So it's problem 2-54. Okay. So we need to construct a table. First column is the year. Second column is, let's call it capital cost. And the third column is the maintenance cost, operation and maintenance cost. And next column is is the overhaul cost. And the last column is, let's put it as benefit. Okay. And how many years do we need to consider? From 0 to 10, right? So we're going to put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the construction cost would be $225,000. So we're going to put negative 225K. Okay? And the salvage value is estimated to be $100,000 after 10 years. So you need to put negative 100K down here. And the maintenance cost, annual maintenance cost would be $85,000. So it's going to be negative 85K. Okay? And you need to put negative 85K at the end of each year up to year 10. Okay? Okay, of course, we don't have any maintenance cost at the end of year 0, and there will be no capital cost here. Okay. What about overhaul cost? It's going to be $75,000 in year 6. So you need to put negative 75K. And all others would be 0. Okay. And the benefit would be estimated as $190,000 annually. So you need to put 190K at the end of each year. Of course, there will be no benefit at the end of year 0. So this is the table of cash flow. So based on this, you can draw the cash flow diagram. Okay. So this is the timeline, right? And at the end of year 0, you have 225K, right, as the capital cost. Again, the arrow pointing down means negative cash flow, which means that you don't need to put negative sign up here, okay? And at the end of each year, so let's say I use different color. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So at the end of year 1 to up to year 10. 3, 4, 5, 6, 7, 8, 9, 10. This would be 85,000, right? Same amount. And at the end of year 6, there is an overhaul cost, which is 75K. So you need to add up 75K here, right? So in total, this is going to be 160K, right? Okay. And the benefit, your benefit would be 190 each year, at the end of each year. Which is 190K. And at the end of year 10, oops, this should be positive because this is the service value. This is going to be your benefit. So at the end of 10th year, you have additional 100K. This amount is 100K. So the total amount at the end of year 10 would be 290K, right? Okay. Okay, so this would be the last problem that we are going to solve from chapter 2, which is problem number 2-55. So identify your major cash flows for the current school term as first cost and operation and management expenses, service values, revenues, overhauls, and so on. And using a week as the time period and draw the cash flow diagram. Okay. So obviously each one of you will have different answers for this question depending upon you and particular schools and its situations, of course. So just as one of the example, we can consider the first cost would be the, let's say, tuition, because you need to pay off your tuition up front, right? And maybe fees for the textbook and some supplies maybe. Okay? And the operation and maintenance cost would be maybe the monthly apartment rent. And maybe food cost as well. Okay? And the service value would be maybe selling your textbook back to bookstore or student union, things like that. after the semester is over, right? And maybe revenue would be, if you have a part-time job during the semester, then the wages and tips going to be the revenues. Okay? If you have a part-time job, tips, the revenue. And probably the overall cost would be something like periodic, midterm expenses. Okay. So basically, using all this information as an example, you may draw the cash flow diagram. Okay. Okay. Now let's move on to chapter 3 of our text, which is about interest and equivalence. Okay. Again, this lecture note is based on Shiming Lee and David Mendever's lecture notes. Okay, so this is the chapter outline. So from chapter 3, we will learn about the concept of time value of money, and then distinguish between simple interest and compound interest, followed by understanding the concept of equivalence of cash flow. And then we're going to solve some problems using the single payment compound interest formulas. And then later on, we're going to talk about nominal interest and effective interest and continuous compoundings. Okay? Okay, so first, let's consider our textbook example 3-1. So let's suppose you've purchased a new $30,000 machine, and you have two choices for your payment option. This is the first choice. You're going to pay the full price right now. In such case, you will have a 3% discount. And second option is to pay $5,000 right now, and then $8,000 at the end of year 1, and $6,000 at the end of each of the next 4 years. Okay. So let's work on the first option. So we are working on the example 3-1, and then first option, which is pay in full. Okay. So we can construct the table of cash flow. And first column is the time. So again is end of year. And second column is simply indicate the cash flow. Okay? And we are considering years from 0 to 5. Okay? And the first option is to pay full amount of $30,000. In that case, you will get a 3% discount. So 30,000 times 3% is $900, right? So you're going to have $900 of discount. So at the end of year 0, you're going to pay 30,000 minus 900, which is $29,100. Okay? And then for the rest of year, you do nothing. Okay? So this is the first option. Of course, the cash flow diagram would be 29,100 at the end of year 0. 0, 1, 2, 3, 4, and 5. Okay? So it's very simple cash flow diagram, right? Okay, then what about the option number 2? So option number 2, which is pay in 5 years, right? So again, we're going to construct a table of the cash flow. End of year. And then second column is the fact cash flow. Again, we are considering years from 0 to 5, right? Of course, 0 means right now. And according to the second option, you're going to pay $5,000 right now. So you need to put negative 5,000 at the end of 0 right now. And then $8,000 at the end of year 1. So you're going to put negative 8,000 and 6,000 at the end of each of the next 4 years. So you're going to put negative 6,000. Like this. Okay? So here the cash flow diagram would be $5,000 right now, and at the end of year 1 you need to pay 8,000, and at the end of year 2, 3, 4, and 5 you're going to pay 6,000. Okay, so these are all the same amount. So this is the cash flow diagram for the option number 2. Okay. And here, if you add up all these numbers, it's going to be negative 37,000. Okay? So my question is, can we compare this negative 37,000 with this number from the first option, negative 29,100, to make a decision which option is better for you? Can we do that? No. Why is that? Why you answer no? Because this number does not provide us exact meaning, because we have ignored the time value of money when you have this number, right? Which means you just cannot add up numbers at different times, okay? So you cannot make a simple comparison between these two numbers, okay? Okay. Then let me ask a question. Would you rather receive $1,000 today or receive $1,000 10 years from now? Definitely your answer would be today. Why is that? Because the money is more valuable today than in the future. Because you could buy a lot of stuff today with $1,000, and you could invest $1,000 today to make more money. And who knows what's going to happen in 10 years. So obviously, you're going to say you'd like to receive $1,000 right now, rather than 10 years from now on. Because, like I mentioned, money has a purchasing power, and money has earning power, and money is a valuable asset. Okay? And people are willing to pay some charges, which is called interest, to have money available for their use, because there is a time value of money. Okay? Then how do you define interest? Interest is what you pay the bank for your home loan, car loan, or your credit cards, things like that, right? So interest is what your bank pays you for the money in your savings account. So I can say that the interest is a kind of rental fee for money. It is a fee paid or fee earned for the use of money. Okay? So in this chapter 3, you will learn about two types of interests: the simple interest and compound interest. Okay? And simple interest is an interest that is computed only based on the initial deposit. So the interest rate is simply multiplied by the number of years. Here, N is the number of years. Okay? So P is the principal money. That is the initial deposited money. and I is the simple interest rate. Okay? So of course, the simple interest should not be used in the engineering economy problems. Okay? So let's take a very simple example from our text, which is example 3-3 for the simple interest calculation. So you have agreed to loan a friend $5,000 for 5 years at a simple interest rate of 8% per year. Then how much interest will you receive from the loan? And how much will your friend pay you at the end of 5 years? So you are working on example 3-3, okay, from our text. So loan of $5,000 for how many years? 5 years at simple interest rate of 8%, right? So how much interest will you receive from the loan? So the interest earned at the end of first year would be initial deposit of $5,000 times interest rate, which is 0.08% at the end of year 1. How much is that? That is going to be $400. Okay? What about interest earned at the end of second year? That's going to be the same 5,000 times 0.08 times, this time you need to multiply it by 2 because it's at the end of second year. That's going to be $800. Okay? The same way, interest earned at the end of the third year would be 5,000 times 0.08 times 3. How much is that? $1,200. So in this way, you can get the interest earned at the end of the fourth year, 5,000 times 0.08 times 4, which is 1,600. And the interest earned at the end of the fifth year would be 5,000 times 0.08 times 5. That's going to be $2,000, right? So the amount due. Oh, okay. So in this case, each year, the amount of money for interest would be increased by how much? By $400. Is that right? So now we can answer for the second question. How much will your friend pay you at the end of 5 years? So the amount due at the end of loan would be $2,000 from here, right? Plus this initial loan amount, which is $5,000, which is $7,000. Okay, so that will be the answer for the second question. Okay, now let's talk about the compound interest. Okay. So the compound interest is the interest which is computed on the current balance, currently unpaid balance, okay, which includes the principal and any unpaid interest from the preceding period. So savings account and loans, credit cards, and engineering economy are based on this compound interest. Okay? And it is a common practice for interest calculation unless specified, unless specifically stated otherwise. Okay? So let's take a simple example from our text, which is example 3-4 for compound interest calculation. To highlight the difference between simple and compound interest, we're going to rework example 3-3 using an interest rate of 8% per year compound interest. How will this change affect the amount that your friend pays you at the end of 5 years? So you are working on example 3-4. Okay, which is loan of $5,000 for 5 years at the interest rate, compound interest rate of 8%. Okay. So we can make a table of cash flow and do the year-to-year based calculation. Okay. So the first column is the year, end of year. Second column is the balance at the beginning of year. At the beginning next column is the interest amount. And the last column is the balance at the end of year. Okay? The balance at the end of year. We are considering 5 years from year 1 to 5, right? 4 and 5. And the original loan amount is $5,000. and interest rate is 8% per year, compound interest. And the interest amount is how much? 5,000 times 0.08, which is $400 at the first year. So you're going to put 400 at the first year. So the balance at the end of year number 1, at the end of the first year, becomes 5,400, right? 5,000 plus 400 becomes $5,400. Now, here's the tricky part. The compound interest is interest which is computed on the current balance, currently unpaid balance. That includes the principal and any unpaid interest from the previous preceding period. So in the next year, which means in the second year, the interest is calculated on this amount, 5,400, not based on 5,000. Okay? So the interest at the second year, would be 5,400 times 0.08, which is $432. Okay? So starting from 5,400 at the beginning of the second year, the interest amount would be $432. So at the end of year 2, the balance would be $5,832. Okay? Likewise, you may obtain the amount due at the end of the third year, fourth year, and fifth year. Okay? Let me just provide you those numbers. But you've got to double check it by yourself at home. Okay? So third year, starting from $5,832, the interest amount would be $466.56. So at the end of year number 3, the balance would be $6,298.56. Okay, and year 4, $6,298.56, and interest would be $503.88. At the end of year 4, it's going to be $6,802.44. And starting from $6,802.44, the interest at the end during the year 5 would be $544.20. And the balance at the end of year 5 would be $7,346.64. Okay? So the total balance at the end of the year 5 is $7,346, almost $47, right? And this amount is a lot larger than the one from the simple interest calculation. From the simple interest calculation, it was 7,000, right? In general, this difference between the simple and compound interest increases as the interest rate or the number of years increases. Okay? is next? Okay. Here it is. Okay. So the debts can be repaid in many different ways. Now we're going to consider 4 different ways of repaying a debt. So we are assuming that the original principal, the original loan amount is $5,000. And the loan term is 5 years. And the interest rate is 8% per year, compound interest. So in this first plan, you're going to pay $1,000 principal plus interest due at the end of each year. So at the first year, the interest amount is $400, which is 5,000 times 0.08 becomes 400. Okay? So the interest payment would be $400 at the first year. And the end of year payment is $1,000 plus $400 interest. So 5,400 minus 1,400, which is $4,000 are left over. So at the second year, the interest amount becomes $320, which is from 4,000 times 0.08, right? And at the end of year payment is again $1,000 plus this interest amount, $320, right? So 4,320 minus 1,320, which is $3,000 are left over at the end of year 2. So we begin with $3,000 at the beginning of year 3. And the interest amount at the year number 3 would be $240, which is from 3,000 times 0.08, right? So end of year payment would be 1,000 principal plus 240 interest. In this way, this loan is fully repaid at the end of year number 5. Okay? Here, in the second plan, only the interest due is paid each year without principal payment. Okay? So the end of year payment in each of the first 4 years would be just $400. And this number 400 is from the $5,000 times 0.08, right? And at the end of year 5, the payment is 400 plus the original principal amount, which is 5,000. So it's going to be $5,400 at the end of year 5. Okay? And in the third plan, at the end of year, you pay equal amount. So you pay $1,252.28 at the end of each year. We see that a series of 5 payments of $1,252.28 repays a $5,000 debt in 5 years with interest rate at 8%. Okay. Of course, you will learn how to obtain these values, $1,252.28, later in chapter 4, the next chapter, I believe. Okay, So here's the last plan. In the last plan, you pay principal and interest in one payment at the end of the 5th year. That is, no payment is made until the end of year 5. Okay? And in this case, because no payment is made until the end of year 5, each year the interest due is added to the debt. Okay? So the amount of debt is increased each year. And at the end of year 5, the total amount of debt becomes $7,346.64. And this amount is paid. Okay? And this graph shows the end of year payment schedules for the 4 different plans. So as you can see here, the 4 plans are different in their repayment structure. That is, the repayment amounts at various points in time. Okay? And the total payments amount are different as well. So what are the similarities? All the interest charges were calculated at 8%, okay, for 4 different plans, which means the total interest paid equals the interest rate times the area under the curve. So the area under the curves are like this in the first plan, and area under the curve would be like this, and area under the curve would be this and this. Okay? And what other similarities you can find? All these 4 plans achieved at the same purpose of repaying the loan, the same loan amount of $5,000 within the 5 years. Okay? So within the 5 years, the original loan amount are repaid. Okay? So if a firm believes 8% was reasonable, it would have no preference about whether it received $5,000 right now or was paid by any of the 4 repayment plans. And all 4 repayment plans are equivalent to each other and to $5,000 now at 8% interest rate. So the equivalence is a very important, essential factor in the engineering economic analysis. Okay? So using the concept of equivalence, we can convert different types of cash flows at different point of time to an equivalent value at a common reference point. Of course, the equivalence is dependent. Equivalence is dependent on the interest rate. In order to facilitate the equivalence computations, we use these notations. So small I represents the interest rate per interest period. Small n is the number of interest periods, and capital P is the present sum of money. Capital F is the future sum of money. Then the single payment compound amount formula is like this. So if you read the text page number page number 85. It shows how to derive this formula. And according to this formula 3-3, we know that a present sum P increases in n periods to P times 1 plus I to the power n. And this relationship, and this represents a relationship between a present sum P and its equivalent future sum F. Okay? And equation 3-4 is another expression of equation 3-3. So those are identical expression. Okay? And here the notation inside parentheses is called the single payment compound amount factor. And we read as finding a future sum F given a present sum P at I over n different periods. Okay? And this single payment compound amount factor can be easily found from the compound interest table in the appendix B at the end of our text. Okay? Also, this appendix B can be downloadable from our Canvas, from our class Canvas website homepage. Okay? So using the same notation, we can derive a compound interest factor to find a present sum P given a future sum F, like this. Okay? So this is called a single payment present worth formula. Okay, so this is all for today. And next time we will solve some problems using this single payment compound interest factor. And then we're going to talk about the nominal and effective interest and continuous compoundings as well. Okay? So please make sure that you read the chapter 3 before you watch the next lecture. Thank you very much. Bye-bye.